you know, just you can ask questions throughout. It's just an opportunity for you to maybe get a little helping hand working problems, just to try and synthesize the lectures. So, so this problem will be on wave solutions in R3. So what did we talk about this week with respect to wave solutions? We kind of finished up our discussion of D'Alembert's solution. We talked some about uniqueness and proving it using energy methods. We also talked about converting inhomogeneous wave problems to a form that we can solve explicitly using Duhamel's principle. And then the last thing that I presented on the recorded lecture was really this method for deriving wave equations in Rn to homogeneous wave equations with non-trivial initial conditions. Okay, so today we'll just dig a little bit more into that. I may just sort of go off script of my practice problem a bit, but let's just set up an initial value problem in R3. So I don't know why I put the arguments there. I didn't put them here. Okay, so here's our wave equation. It lives in the unbounded domain on R3, and t is greater than 0. So it's going to have initial conditions given by the displacement of this three-dimensional medium. And its initial velocity in R3, okay? And in particular, we're gonna say that the initial data are spherically symmetric. Okay, so what's that mean? It just means that phi of x can be written as phi of r, and psi of x can be written as some function psi of r that only depends on the distance from the origin, okay? Where r squared is equal to x1 squared plus x2 squared plus x3 squared, okay? So I'm gonna pose a sort of part A problem here, which is that I want you to show that the general solution, okay, to the initial value problem can be expressed as the following: u of RT is equal to 1 over r capital F of r plus t plus g of r minus t. Okay. And the hint, okay, is to basically just substitute has 3 t's, okay, into the IVP, okay, compute the derivatives, okay, and check it satisfies the IVP, okay? So essentially it's just the application of the chain rule in higher dimensions, okay? But you have to go through those steps, in particular in the x dimension. In the t dimension, it's pretty straightforward, but in the x dimension, it requires a little more work, okay? So why don't you take maybe 10 minutes to chew on that and see where you are, but you can chime in with questions, or if you want to drop me a question in the chat while you're working on it. Happy to answer any questions. Okay.